Hello guys, welcome back to my channel. Now in this lecture, we will be covering say our second topic called data preparation. In this, we will be going through how to add an index field using Python, how to change misleading field values, how to re-express categorical fields, how to standardize numeric field using Python, how to identify outliners. Now we will be going to our presentation. Now, data preparation. Data preparation is an essential step in the data analysis process. This involves cleaning, transforming, and preparing raw data for use in machine learning algorithms. To unlock the full potential of your data, it's crucial to address inconsistencies, handle misleading values, and ensure consistency in data representation. In this PPT, we will explore a range of Python based techniques for a data preparation. We will cover key concepts like adding address in fields, adding index fields, transforming misleading values, re-expressing categorical fields, standardizing numeric data, and identifying the handling outline. Now, overview of key data preparation techniques. First, adding an index field. Second, changing misleading values. Third, re-expressing categorical fields. Fourth, standardizing numeric fields. Now, in adding an index field, give each data point a unique ID for better tracking analysis. This helps preventing duplicates and ensure accurate data combining. Now, cleaning up errors or misleading data to get accurate result. This might involve fixing wrong values or fixing in missing values. Re-expressing categorical fields. Many machine learning models need numbers, so we can change categories, example like gender or city, into numbers. This makes the data read for analysis. Standardizing numeric field. When numeric fields have different scales, we make them consistent. This ensures fair comparison and avoid bias towards large numbers. Adding an index field using Python. Now, here is a code snippet that I have given. In this code, there is a import which is a keyword and we are importing panda library to our program as pd data pd.data frame. We are instantiating the data with data frame name Alice, Bob, Charlie, age 25, 30, as you can see. Data ID, we want to check the length of ID, so we use range length data. Now, this code demonstrates a common data preparation techniques, adding a unique index field to a data frame. The range length data function generates a sequence of integers starting from 0 and ending at the length of the data frame, representing a unique identifier for each row. This sequence is then assigned to a new column named ID, effectively creating a unique index field for the data frame. This is particularly useful for tracking individual data points, especially in scenarios where data merging or combination is required to prevent duplicate or ensure accurate data association. Now, changing misleading values using Python. In this section, we will dive into a common data preparation steps. Handling misleading values. Often, data sets contain inconsistencies such as misspelled words, incorrect entries, or misleading information. To ensure data accuracy and prevent biased analysis, it's crucial to address these misleading values. Imagine a field representing gender in a dataset. It might contain variations like female, femme, woman, and etc. To create a consistent and reliable data set, we need to standardize these values. One effective approach is to replace them or consistent placeholder such as NA are not applicable. This standardization ensures uniform representation and enables accurate processing by machine learning algorithms. Now jumping to the next slide. Now, re-expressing categorical field values using Python. There are three ways to re-express categorical field in Python. First, one hot encoding. In this, create binary columns for each unique category, including presence or absence. Second, label coding. In this, assigning of a unique numerical label to each distinct categories maintaining order. Third, ordinal encoding. Map categories to numerical values based on a predefined order reflecting inherent ranking. Standardizing numeric fields using Python. Now, there are three ways. Z-score standardization. In this, it transforms value by subtracting the mean and divide the standard deviation. This process centers the data around 0 with a standard deviation of 1. This technique is particularly useful when dealing with data that has a skewed distribution of outliers, making it more suitable for machine learning algorithms that assume a normal distribution. Min-max scaling. In this method rescales values to a range between 0 and 1, preserving relative difference between data points. This technique is effective when working with datasets when the scale of feature varies significantly. By normalizing the range, it ensures that feature with larger magnitudes don't dominate the analysis. It commonly used in algorithms like k nearest neighbor and neural networks where feature scaling is crucial for optional performance. Robust scaling uses the median and interquartile range for standardization, effectively mitigating the influence of outliers. Unlike Z-score standardization, which is sensitive to outliers, robust scaling is less affected by extreme values. This makes it a valuable technique when working with data that may contain unusual and erroneous entries. Now, identifying and handling outliers using Python. There are three methods through which we can identify and handle outliers. First, IQR method. In this method, we calculate the interquartile range and move data points outside the range. In Z-score method, we identify data points with Z-score exceeding a predefined threshold. Inspection. Use in visualization like box plot or scatter plot to identify outlier pattern. Now to the next slide. Now we are on the conclusion. Putting it all together, data preparation involves cleaning, transforming, standardizing, and handling outliers to ensure data accuracy, consistency, and suitability for analysis and modeling. This process includes adding missing values, correcting errors, converting data types, standardizing numerical fields using techniques like Z-score standardization, min-max scaling, and robust scaling, and identifying that handling outliers using method like IQR method, Z-score method, and visual inspection. Now, evaluating the impact of each step on our analysis and model performance is crucial to assess effectiveness and identify potential improvements. Now, we will be continuing in next lecture. Till then, bye bye, take care.